Now we're going to focus on scientific notation. It's a number written as a coefficient times 10 raised to a power. The coefficient has to be between 1 and 10, greater than 1, less than 10. So if you have a number that's larger than 1, you're going to have a positive exponent. For example, this number, 36 billion, that's a very large number, way bigger than 1. So that means that when we write it in scientific notation, we're going to move the decimal to be between the 3 and the 6. That'll give us a coefficient of 3.6 between 1 and 10. And then times 10 to the, and notice that our exponent is a positive value. It's a positive 10 because it took 10 moves of the decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, in order to make it 3.6 as our coefficient. If you have a number that's less than 1, then you're going to have a negative exponent. For example, 0.00036 is a number that is less than 1, and so it's going to be written by moving the decimal between the 3 and the 6, giving us a coefficient of 3.6, which is a number between 1 and 10, and then we're going to have times 10 to the, and our exponent is going to be negative 4, negative meaning it was a number that was smaller than 1, and 4 being how many positions we had to move the decimal, 1, 2, 3, 4, in order for our coefficient to be 3.6. To put it back into standard form, if the exponent is positive, we're going to make the number larger than 1, which means you're going to move the decimal to the right. For example, 5.94 times 10 to the positive 7. Because the 7 is positive, I need to change 5.94 to be a larger number. And to do that, the decimal gets moved to the right, and so it's going to be 1, 2, 3, 4, 5, 6, 7, giving me the number 59,400,000. To put it back into standard form, when you have a negative exponent, you need to make the number less than 1. You're going to move the decimal to the left so that it becomes a smaller number. For example, 5.94 times 10 to the negative 7, I need this to be a smaller number, so I'm going to move it 7 places to the left, and that's going to give me 1, 2, 3, 4, 5, 6, 7. This number here, 0.000000594. So scientific notation is used to make it easier to work with very large and very small numbers. Changing large numbers to scientific notation means you're going to take your decimal and you want to move it between the first two numbers so that you have a coefficient that is between 1 and 10. And then however many spots you had to move the decimal is going to tell you what your exponent is. And if your number was large to begin with, you have a positive exponent. And if it was small to begin with, you're going to end up with a negative exponent. Here, the decimal has to be moved between the first two non-zero numbers, which are 4 and 8, giving me a coefficient of 4.8, which is a number between 1 and 10, times 10 to the, it's negative because it's a really small number, and 6 is how many spots I had to move the decimal. So changing very small numbers, move the decimal point to the right to make a number between 1 and 10. Use a negative power of 10 to show how many places the decimal was moved, and then you're done. Changing back to standard form, you're going to look and see if your exponent is positive or negative. If it's positive, you need a larger number, which means you're going to move the decimal to the right. If it's a negative exponent, you need it to be a smaller number, which means you'll move your decimal to the left in order to get back into standard form. Write the following numbers in scientific notation. So here, this has a very large number, larger than 1, so it's got to have a positive exponent. And then I need to move my decimal to be between the first two non-zero numbers, which is the 4 and the 5. So I'm going to have a coefficient of 4.5 times 10 to the positive, and how many spots do I have to move it? 1, 2, 3, 4, 5. So it's going to be 4.5 times 10 to the 5. This is a really large number, so again, we're going to have a positive exponent. I'm going to move the decimal to be right after the first non-zero number, which is 8. So we're going to have 8 times 10 to the positive 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this will be 8 times 10 to the 13. This is a really tiny number, so it's going to be times 10 to the negative exponent. I'm going to move my decimal all the way to here. So my coefficient is going to be 2.0. I'm going to include both of these guys at the end there. So it's going to be 2.0 times 10 to the negative, and I'm going to move my decimal 3, 6, 9, 12, 15, 18, 21, 24, 25 spaces. So this will be 2.0 times 10 to the negative 25. And then finally, this number is less than 1. It's smaller, so we're going to have a negative exponent. I'm going to move my decimal to be right after the first non-zero number, which is going to be here. We're going to have a coefficient of 6.56 times 10 to the negative, and I have to move the decimal 1, 2, 3, 4 spaces to get there. So 6.56 times 10 to the negative 4. Now I'm going to write these in expanded form. First, I'm going to look at the exponent and notice that it's a negative value. That means this number should be smaller than 1, smaller. To make it smaller, I need to move my decimal to the left, and I'm going to move it to the left 6 spaces, which is going to give me 0.000000987. Notice that it was here, and we move it 6 spaces to the left. 1, 2, 3, 4, 5, 6. All right, 3.4 times 10 to the positive 2. Positive exponent means it's a larger number, so move the decimal to the right to make it a bigger number. So 3.4, if I move this decimal place 2 places to the right, I'm going to get 340, a larger number. 6.02 times 10 to the 23rd. That's a positive 23, which means that I need to make this a larger number. I'm going to move the decimal 23 times to the right, and that's going to give me this very, very huge number. Letter D, 1 times 10 to the negative 9. The negative exponent means that it's a smaller number. So I want to move the decimal to the left, and when I move it to the left 9 spaces, I'm going to get 0.000000001. Or we move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces to the left to end up with this number here. So now you're going to do some practice, and then you're going to submit a picture of your work on Canvas.